You know, it's pretty amazing when you stop and think about it. The internet just works. I mean, every single email you fire off, every video you stream, it all just shows up, perfectly intact. But what's really going on behind the scenes to stop our digital world from just falling apart into chaos? Well, today we're going to pull back the curtain on what I like to call the internet's secret handshake.
Now, let's really think about that for a second. We're talking about trillions of bits of information flying all over the planet every single second. That's your family photos, that super important work file, even this explainer you're watching right now. It's all just data zipping around. So why isn't it all just a garbled mess? What stops a 1 from accidentally flipping into a 0 along the way?
Well, the answer really starts when you realize there's this core problem, right? We have this perfect, super precise digital information, but it has to travel through our very imperfect and honestly kind of messy physical world. And that, right there, is the internet's fragile foundation.
See, everything you do online, literally everything, gets chopped up into the tiniest possible pieces of info. We're talking bits, right? Just ones and zeros. And these little bits have to go on a real physical journey. They're pulsing through copper wires as little jolts of electricity, or flashing through fiber optic cables as light, or even surfing the radio waves to get to your Wi-Fi.
And that journey? Oh, it's a dangerous one. As our source material points out, these physical paths are super noisy. Signals can get weaker the farther they go. That's something called path loss. Or they might bounce off buildings and get all jumbled up, which causes multipath fading and other interference. Any of that stuff could easily flip one of our precious bits and totally corrupt your data.
Okay, so how in the world do we protect against this constant threat? Well, the solution is this incredibly clever, really elegant system of error checking. Think of it like a secret seal for every single chunk of data. The easiest way to get this is to think about it like this. Imagine you're sending a super important letter way back in the day. What do? You'd fold it up and you'd put a wax seal on it, right? Now that seal doesn't hide what's in the letter, but it proves one thing, that it hasn't been messed with on its journey. If that seal is broken, you know something is up. Well, the internet does basically the exact same thing, just for your data.
And this whole digital handshake process is actually pretty straightforward. It's just 4 steps. First up, the sender and the receiver agree on a secret rule. You can think of this like their own unique stamp for the wax seal. Then the sender uses that rule to create a one-of-a-kind seal just for that data. Third, they stick that seal right onto the data. And finally, when it shows up, the receiver checks the seal to make sure everything's still good. All right, so what is this digital secret seal in the real world? It's time for the technical name. It's truly one of the unsung heroes of the internet, and it's called the cyclic redundancy check, or, as you'll usually see it, CRC.
And yep, it's exactly what we've been talking about. It's a really powerful way to detect errors. Now, that's a key point. It's for detection, not correction. Its only job is to raise a red flag and say, hey, something went wrong here. That little special code is our digital wax seal, and its whole reason for being is to check the integrity of the data.
Okay, so let's break down how our analogy maps to the techie terms. It's actually pretty simple. The message you're sending, that's just the data, which we call D. That secret rule, our stamp, that's a pre-agreed thing called the generator, or G. And the unique wax seal itself, that's a little chunk of extra bits called the redundancy bits, or R.
So here's what the sender has to do. It takes your data, the D, and it runs a special math problem on it, using that secret rule, the G. And the answer to that problem, that's your unique seal, R. Now, here's the really clever part. That seal is totally 100% dependent on the data. If even a single bit in that data changes, the math gives you a completely different seal. It's super sensitive.
And just like you'd put the letter and its seal in the same envelope, the original data and this new CRC seal get bundled up and sent out across the network together as one single package. They're locked together, ready for the drip.
All right, so the package arrives. Now it's the receiver's turn. It does something critical. It takes the data it just got and it runs the exact same math problem on it, using that same secret rule, that generator. This makes a brand new seal, calculated right there on the spot. And then comes the moment of truth. It compares the seal it just made with the seal that came attached to the data.
And that comparison, it leads to a super simple but super powerful black or white result. There's no kind or right. The data is either perfect or it's not.
So if the two seals match, perfect! The seal is intact, the data is accepted, it's 100% correct, and everything just keeps on chugging along smoothly. But if those seals don't match, that means only one thing. The data got corrupted somewhere. The seal is broken. The receiver doesn't even try to fix it. It just throws that bad data in the trash and asks the sender, hey, can you send that again?
Okay, so now we know how the secret handshake works. But let's take a step back and talk about the absolutely mind-boggling scale of this. This isn't some weird, obscure process happening in a corner of the internet. It's the fundamental guardian of pretty much everything you do online. I mean, every single time your phone grabs a Wi-Fi signal, CRC is happening. Every time you plug in an Ethernet cable, CRC. Every file you download, every video you stream, yep, CRC is there, silently checking every last little packet of data. It's even happening inside your computer, checking the data coming off your hard drive or your SSD to make sure it's okay.
So just how often is this happening? The number is, well, it's almost impossible to wrap your head around. We are talking about trillions and trillions and trillions of these checks every single day, just constantly safeguarding almost every bit of data moving anywhere on the planet. So here's the main takeaway, the thing to remember. This simple, elegant little process, CRC, is the reason our digital world actually feels reliable. It's that unsung hero working in the background, making sure your important files don't get scrambled and your favorite show doesn't just turn into a pixelated mess of digital noise.
And that kind of brings us to a final thought, right? This technique has been a workhorse. It has served us so well for so long. But now, we're moving into an age with insane data speeds and networks that are getting more and more complex. So you have to wonder, can this simple secret handshake keep up? As our digital world gets even faster, can the seal still hold?